Alright, let's build our first subtractive synthesizer signal path patch in VCV, and we are going to start from the end with the audio output. So let's grab audio output. Yeah, for the purposes of this video, I'm going to use modules from the VCV base collection. So here's our audio out. We have 2, 8, and 16 channels. 2 is enough for me. Output to headphones in my case. I do have a couple of extra modules just for convenience. So scope is also from VCV base. Here it is to display waveforms of our oscillators. I do have a spectrum analyzer from Bog Audio, which is going to be handy when we'll take a look at the filter. And I also have a cable coloring module from Inkland. Now, you can use cables with all the different colors in any way you like, but developing a habit of coloring cables in a way, for example, as when red is for audio, blue is for clock trigger gates, yellow is for volts per octave, and green is for modulation, is going to save you so much time. So shout out to all the people pushing that idea and habit forward. And yeah, this diagram is a module from Submarine. So let's go back to the slide and grab our sound source, which is going to be an oscillator. So oscillator, voltage controlled oscillator in our case. Let's take sine, plug it into the scope, decrease display time, and here's our sine wave. And I want to show you something interesting. A perfect sine wave should not have any extra harmonical content. And look what happens when I plug it into the spectrum analyzer. It should only have this peak, but it has 4 more. So I don't know what's happening there. But we are going to assume that that is a perfect sine. And I'm going to plug that into audio out, and it's going to get loud in a second. Great. Now we need a way to level that audio, and that is when an amplifier comes in handy. So let's grab an amplifier, a voltage controlled amplifier in our case. So plug the sine into an amplifier, close it all the way down. Now I'm going to assume that there is no level adjustment on the audio output, so I'm going to return it to the original position. And now plug our amplifier to the audio output. And now when I open an amplifier a little bit, get audio out. Great. Let's go back to the slide. So now let's add a filter. Filter, voltage controlled filter in our case. So now let's first plug our sine into scope. So here's our sine, but it should not have any extra harmonical context. So let's actually take a triangle wave. Here's our triangle wave. From scope we'll go into the filter. And from low path filter out, I'm going to go into spectrum analyzer. Open filter all the way up, and from spectrum analyzer go into the VCA or an amplifier. So what is happening here? A low path filter subtracts high frequencies and allows only low end through. So have a listen to what's happening and take a look at the spectrum analyzer. So it removes high end and allows only low end through. And when I use the high path filter, it is going to subtract low end and let only high end through. So let's have a listen. Cool. Let's go with the other wave. That is sawtooth wave. Cut off all the way up. So low path filter first. Now high path filter. the other way around. That is a very nice sounding wave. And finally, a square wave. So low pass filter first. And now a high pass filter. Cool. Now, the thing is, when I open an amplifier, we're just getting that beeper. I'm not pressing anything on the keyboard or doing anything with mouse. It's just basically the oscillator is just oscillating in the, we're getting that oscillation or that beeping audio. And that doesn't really mm, that's not really a synthesizer for me. So we have to trigger that in some, we have to open that amplifier in some way. And for that, we have to grab a module that is going to represent our keyboard, and we will have to grab an envelope. So first, let's grab a MIDI to CV module. Now, MIDI is a musical instrument digital interface. MIDI is basically a protocol which transmits control messages. MIDI does not transmit audio. MIDI just basically says, play me this note at this level, and that's it. Now, I'm not a keyboardist and I do not have a dedicated MIDI controller, so I'm going to switch Windows MIDI to computer keyboard and mouse. And now, if we take a look at the slide, to modulate or to control volume output of an amplifier, we need an envelope. So let's grab an envelope, ADSR envelope. Here it is. And it has a gate input. So if we'll go back to the slides and look at the signals, gate signals carry on and off. So we need to turn that envelope on. So we're going to grab a blue cable from the gate out of the MIDI to CV and put it into gate in of the envelope, and then envelope output is going basically to open our amplifier. So now I'm going to raise it all the way up, but there is no audio until I press a key. Great, we're getting output, but I'm pressing different keys and I'm getting the same note. So to fix that, we have to grab a volts per octave output, which is a signal which represents pitch or note or tonality. So yellow for volts per octave, and it is going to go into the volts per octave input of the oscillator. So now when I play notes, I get different notes. Let's actually choose maybe a sawtooth wave. Okay, great. Let's go back to the slide. And we've stopped at the envelope. So let's break down the envelope. It has 4 stages set at the moment. So when I press and hold the key, it goes 3 of them and then the 4th one. So I'm going to remove decay, sustain, and release completely and leave only attack. So on the dedicated slide for the envelope, we now only have the first stage, which is attack time, and our volume level is only going to increase. So once I press that key, it's going to increase and then just drop. So now if we add decay, we will get a second stage, and after I press a key, it's going to increase and then drop, and then decrease a little bit. That is our decay time, second stage. Now let's go back to VCV and add a sustain level. So when we have a sustain level set, when I press and hold the key, note is going to sustain while I'm still holding that key. And then it just goes away. But so here's the sustain level, which is the third stage. But there is no release, so let's add a release time. So now when I press and hold the key and after I release it, volume is going to fade away. And that is the fourth stage, which is the release time. So that is the breakdown of the envelope. And for example, if you remove attack, remove release and sustain, and only leave a decay, you will get some plucky sounds such as percussion hit. And you can play around with it, basically. Yeah, let's now take a low frequency oscillator and set it to modulate, for example, a filter cutoff frequency. So an LFO, which is the low frequency oscillator, let us take a sine wave from it and actually plug it into our amplifier. And we're not hearing anything because it is oscillating at 2 Hertz, and that is basically 2 pulses per second. But when I raise it, we get the audio output, but it's not primary function of the LFO. It is usually used to modulate other parameters. So let's do that. We will grab green cable for modulation and put it into cut of frequency of the filter. I'm going to close the filter a little bit and now open the control voltage input and let's play some notes. Oh, we need to increase sustain level, maybe. That is our sine wave, that is LFO with the sine wave modulating cutoff frequency of the filter. Let's increase it. So this is it. But typically, in the complete synthesizer system, you will meet cases when LFO is modulating a pitch of the oscillator, so it creates a vibrato effect. But it is not very easy to make in the VCV because volt per octave input is taken by the pitch information from the MIDI to CV. But what we can do is we can grab a mixer such as this one, put our volts per octave input here, and then our sine modulation here, and then mixer will go here for modulation. And now when I press a note, here's what we get. And that is basically a tremolo effect. I'm sorry, not tremolo, a vibrato effect that we've been talking about. Great. And now let's finally grab a noise generator. So let me unplug our wavefront spectrum analyzer, and first let's actually go into, let's just remove envelope from amplifier, and now it's gonna get a little bit loud. So white noise is going to be random voltage all across the frequency spectrum. Pink noise is going to be more on the low end, less on the high, red even more on the low end. Then violet, I think, is more on the high end and lower on the low end. blue even higher with the high frequencies, gray, something in between, and black looks like a reverse white noise to me. So we can also use noise to modulate. Let me redraw everything. So now we can use noise to modulate filter cutoff frequency because LFO is now modulating pitch of our oscillator. So let's do that. Give me a second. We need this. First, and grab our sawtooth wave, first in the filter, from filter into the spectrum, from spectrum to VCA, close VCA. Now open it with an envelope. And now I should actually remove tremolo, I'm sorry, vibrato, because otherwise we will not hear that cutoff frequency modulation very well. So now white noise, green for modulation, is going to modulate cutoff frequencies. So let's listen. Hear that dust. And without modulation. This is it. This is really cool. All right, so that is pretty much it for the basic subtractive synthesizer patch. Think East Coast synthesis. And I'm going to conclude it for this video. So in the next video, we are going to build upon this and go a little bit crazy with West Coast synthesis. See what we get.